let's have a look at the hydration of alcohols. So hydration is a reaction where we will add water, and we're going to add water across the double bond in an alkene, and that will give us an alcohol. To carry out this reaction, the reagent is obviously going to be H2O, although that's going to be in the form of steam. So this would be in fairly high temperatures, and the conditions that we need to talk about is the catalyst that we'd use, which is either a concentrated phosphoric acid catalyst or a concentrated sulfuric acid catalyst. So a general equation for this: there's our alkene and there's the water. Break the double bond on one of the carbons, we'll get the OH group. There we go, and the rest of the water, the hydrogen, is going to be on the other carbon. So there's the hydration. Have a go at doing it for ethene. Well, just need to make sure that the double bond breaks. Hydrogen on one carbon, OH on the other. There's our product, ethanol. Propene next. Need to be a little bit more careful with propene. As we can see, we're going to break the double bond, and if we think about how our water is going to go across the double bond, then the hydrogen could either go on that carbon, which would leave the OH on the first carbon, or it could do it the other way around. So the hydrogen might end up on the first carbon and the OH on the second carbon. So this will happen when we've got an unsymmetrical alkene such as propene. So this is going to give us two different products. So with propene and water, I'm just going to draw out the molecule with the carbon-carbon double bond broken. So I'll draw it out twice, and then we can see the two possibilities. So in the first one, I've got the OH group on the second carbon in the middle, and there I've put it on the first carbon. So two products, see if you can name them. With cyclohexene, I've drawn it out skeletally. You might think that there are two possible products here, but there's only one way that this can go across the double bond. So the double bond's going to break. We're going to get a hydrogen on one carbon and my OH group on the other. Of course, on a skeletal, we're not going to show that hydrogen, so let's get rid of that other hydrogen. And there's the skeletal formula for my product, which is cyclohexanol. The mechanism for the hydration. So we want to show the alkene, remembering we're going to show curly arrows for how we're going to form the alcohol. So there we are, starting with the simplest one, which is ethene. We might be tempted to bring along water to start with, although please don't do that, bad idea. So the first thing that we're going to introduce is a hydrogen ion. So this is from the acid catalyst. So where are the electrons? Don't be tempted to start with the hydrogen ion. Remember, the hydrogen ion has no electrons, so the double bond is the electron dense source of electrons, so we want a curly arrow from the double bond going to the hydrogen ion. That's step one. See if you can work out what that will make. Okay, so the double bond has broken and we've formed a bond between one of the carbons, doesn't matter which one. So I've picked the carbon on the left, and there's the bond to the hydrogen. Of course, we started off with a positive charge, we can't suddenly lose that, so the carbon on the right hand side is now short of an electron, so it's lost its electron, so the positive charge is now with that carbon. See if you can work out what happens. So remember, we need to add an OH group. Now's the time to bring your water along. Who has the electrons? Well, of course the water has the electrons, so we want the lone pair on the oxygen, and there we're forming a bond with the positively charged carbon. See if you can work out what that will make. Well done if you got that. Something not quite right about it. See if you can spot it. Well done if you saw that the oxygen needed a positive charge. So we've moved the positive charge from the hydrogen to the carbon. It's now on the oxygen. That oxygen wants its electrons back, so we can just kick out a hydrogen ion, which will give us our desired product, which remember was ethanol. So here's the ethanol. In water, in red, there's the water, and not forgetting, we end up with a hydrogen ion that we started with at the beginning of the mechanism. So there it is, we've regenerated the hydrogen ion that we had there, showing it's a catalyst. Let's have a go at doing but-1-ene. So have a go at this. Maybe pause the video before you check your own answer. So but-1-ene is going to cause us more problems. So more than one possible alcohol that we'll make here. Mechanism starts the same, double bond breaks, going to the hydrogen ion. I'm going to go down either side of the page here. So see if you can draw the two intermediates. So the hydrogen can either attach to the yellow carbon or the blue carbon. Down the left hand side of the page, I'm going to attach it to the yellow carbon, and down the right hand side of the page I'm going to attach that hydrogen to the blue carbon. Okay, so those are the two possible options, which leaves me with either a secondary carbocation on the left hand side or a primary carbocation on the right hand side. Continuing with the mechanism, I now want to introduce my water. So these water molecules will come in and attack those carbocations like so. So here's my two possible products. Left hand side, the water is on the second carbon, right hand side it's on the first carbon. Remember that oxygen is positively charged, so it's lost its own electrons, so positively charged. What do we do now? So we need to kick out the hydrogen ion so the oxygen can get its electron back, like that, or like that. So nearly there. Let's draw the final product in skeletally, just to save time. There we go. So there's butan 2-ol on the left, or butan 1-ol on the right hand side. And of course in both cases we've regenerated our hydrogen ion.